Today, we're diving straight into a silent, high-stakes race, a race to secure our entire digital world from a totally new kind of threat. We're going to explore how quantum computing, AI, and blockchain are all colliding, and what that means for the future of trust itself.
Just think about your digital life for a second. Everything you do online, sending an email, checking your bank account, all of it is secured by cryptography. It's kind of like a complex, invisible lock that keeps all your information safe and sound.
And that's the heart of the problem we're looking at today. There's a new type of computing coming, one that could basically create a master key, a single key capable of opening almost every single one of those digital locks out there.
To really get why this is such a big deal, we first need to understand the fortress we've already built. For decades, our digital security has relied on a really brilliant and powerful design.
This right here is the foundation, asymmetric encryption. The idea is you have two keys. There's a public key which you can give to anyone, and they use it to lock a message. But, and here's the magic, only one thing in the universe can open it, your corresponding private key which you and only you control. It's been incredibly secure because it's based on math problems so hard that our best supercomputers would literally take billions of years to solve them.
And we're not talking about some niche technology here. This two-key system is the bedrock of modern society. It's what secures government secrets, corporate data, and the entire global financial system. We've pretty much put all of our trust into the strength of this one type of lock.
But the rules of computing are about to change, and change dramatically. The master key is coming, and its name is quantum computing.
So here's where the power difference comes from. A classical computer bit is simple. It's like a light switch. It's either on or it's off, a 1 or a 0. But a quantum bit, or a qubit, can be both on and off at the exact same time. It's a wild concept called superposition, and it lets a quantum computer explore a mind-boggling number of possibilities all at once.
And that one single difference, well, it changes the game completely. It gives quantum computers a kind of computational superpower that our current systems just have no way of competing with.
And here's exactly how that master key works. There's an algorithm called Shor's algorithm. It's designed specifically to run on a quantum computer, and it can solve those impossibly hard math problems I mentioned earlier. It factors huge numbers with incredible speed, turning our unbreakable locks into dust.
Now, this sounds pretty apocalyptic, I know, but it's not. The same brilliant minds who saw this threat on the horizon are already in a flat-out global race to build the next generation of digital security.
So meet the hero of our story, Post-Quantum Cryptography, or PQC. Now, these aren't quantum algorithms themselves. They're actually brand new classical algorithms, but they're built on different math problems, ones that are believed to be hard for both classical and quantum computers to solve.
And the search for a solution isn't just a bet on one single idea. Researchers are developing multiple families of these quantum-proof locks, as you can see here. You've got lattice-based, code-based, hash-based. Each one is built on a different kind of hard math problem. And this diversity is absolutely crucial, because if a weakness is ever found in one approach, we'll have others ready to step in.
You know, this isn't all just happening in a vacuum. The U.S. National Institute of Standards and Technology, or NIST, is leading this massive global effort to test, vet, and standardize the very best of these new PQC algorithms. They're making sure the new locks we're going to use are truly secure.
And these aren't just theories. They are real algorithms with actual names, like Kyber, Dilithium, and Sphinx Plus. These are the leading candidates that are being implemented and tested right now to become the new global standards for keeping our data safe.
But the story doesn't end with just replacing the old locks. The next step is to build a fundamentally smarter, more resilient fortress by combining our new PQC locks with other cutting-edge technologies.
As the cryptographer Martin Luther says, the real revolution is in how these technologies all work together. This isn't just about playing defense. It's about creating entirely new, intelligent, and even self-governing systems.
A perfect example of this is a next-gen hybrid system. Think of it in 3 layers. First, a quantum layer generates true unpredictable randomness for the strongest possible keys. Second, the post-quantum layer uses those new algorithms like Kyber to lock everything down. And finally, an AI-driven control layer acts like an intelligent security guard, constantly monitoring for threats and adapting the defenses in real time. It's not just a stronger lock, it's a living defense system.
A key piece of this new infrastructure is the smart contract, which runs on a blockchain.
Just think of it like a digital vending machine. You put in the required input, and it automatically executes the deal without needing any middleman.
So now imagine you combine that with AI. You can have an AI managing these smart contracts, making decisions, allocating resources, and enforcing rules all across a decentralized network. The fortress isn't just strong anymore, it's intelligent.
And again, this is not science fiction. This future is actively being built on blockchain platforms you can look up right now, like Polkadot, Algorand, and specialized quantum-safe platforms like a Billion Blockchain.
So we've talked about some really high-level concepts. But what does this silent arms race actually mean for you today?
Everything. What's at stake is the security of your online banking, the privacy of your emails, your crypto holdings, corporate trade secrets, and yeah, even the highest levels of national security. Everything that is currently encrypted is vulnerable.
And this is not some far-off problem. The timeline is speeding up. In fact, many experts are looking toward 2025 as a critical year. That's when the first official standards for these new quantum-proof algorithms are expected to be finalized and start rolling out. So the transition isn't coming, it's already underway.
Ultimately, we are living through a fundamental shift in digital security, a race to rebuild the very foundations of trust online. The question isn't if this change is coming, but whether we'll be ready when it arrives.